Yeah, okay, so this next session is, we talked about in the first session with the sets, and then second session extend our horizon with logic rules. Now we have perhaps something more to talk about. And for the first invited talk, we'll have Guido van Rossum, and then afterwards we'll have some more talks. I will pass the torch to Amy to introduce Guido. And
Okay, all right, thanks, Tunji. Thank you to everybody. But I'm so excited and honored to introduce Guido van Rossum, the creator of the Python programming language. I assume by now everybody knows. And I'm so excited because that's the language I do my research and teaching on for 20 years, and just and allow me to think things I didn't think about before, and just really enjoying it. And of course, I convert just about every student to use it. And they don't have me to thank for, they really have Python to thank for. Okay, but anyway, so Guido is currently a distinguished engineer at Microsoft. And before that, he had I guess a short retirement where he apparently wrote the whole new Python parser generator, and that's much more powerful. And before that, he worked at the Dropbox and Google, and just all the other experience before. But anyway, and he worked at the CWI, which is the Netherlands National Institute of Research for Math and Computer Science, where he worked on the ABC programming language and the Amoeba distributed operating system. That's where he invented the Python. And I wanted to mention ABC because that's the connection between Settle and Python. And in fact, being somebody who loved programming, especially programming algorithms, actually love programming in all programming styles, except I have to use different language for different things. But at one point when I really missed the Settle, that's let me find Python, and I have since stayed with Python. And that's just the first day of programming Python improved my productivity infinitely, I would say. I already did things I didn't think I would ever do at all, right? So usually at this point, you can see he had this beautiful Q&A, has all these crazy things you have to do, both most interesting technically and something I never thought about, like lawyers, and to actually make Python to what it is. So usually at this point, of course, I'll give the floor to Guido, but I thought I will do just two things. First, of course, I will let him say something, and then what I will do, I will display his abstract, so people can start to think questions you have already. We already have collected some questions, and of course I prepared some, and I will start with just a little bit of myself where people ask more questions. Okay, so Guido, you want to say something?
Well, I'm honored to be here. That was a fantastic introduction. I like that you started at the end and went backwards.
I'm sorry.
No. That was actually a good idea, because the connection with Settle came through Lambert Meertens, who spent a year somewhere in New York with Robert Dewar, where apparently he came in touch with Settle. That's sort of the origin story for ABC that I remember, and I may have told it all wrong. The sad thing, of course, is that Python in practice has very little connection with logic programming. It's object oriented. It is very procedural. There are mutable data structures. It's been eye-opening to attend most of this little conference so far this morning. I had to step out for an hour, unfortunately, for a terrible work meeting. I'm not sure what to say next. I don't do talks anymore because they stress me out. So I figured I'd open the floor for questions. And I'm really totally depending on everyone here, especially Annie, of course, to sort of come up with interesting questions to get me talking about stuff.
Okay, I will display his abstract. Actually, Guido, I don't know if it's just me, but your microphone sounds a little bit remote, your sound to me, compared to everybody else.
Yeah, sometimes it works well, sometimes it's off. Yeah, perhaps.
How about I get rid of these stupid headphones and I switch
that's
to
sometimes
a different setup? Yeah. Yeah, I never.
Okay, I'll get my slides ready. Well, okay.
How about now? How is my sound now?
Much better.
Sounds better. Okay, excellent.
Much better. Okay, this is the abstract, and I took the liberty to make some coloring. So I guess the blue is top level. It looks a lot when I actually start to think about question. I'm just amazed how neat and organized, right? So the blue is the 3 top level things, and these red are more medium level, and the greens are like examples. Okay.
Well, you fit it all on one slide.
I did have to make a smaller font to make it happen. But of course, I don't want to switch slides in between that. But it's really amazing to fit.
How do we do this? How do we organize the questions?
Yeah, so well, I mean, I
would like to ask a question, or
we can start to do the raise hands. We can start to
my system doesn't have any button that lets me raise any hand anywhere.
Just go ahead.
Everybody can raise hands.
I'm just so everybody knows.
When it's enough.
Just a second, I will
ask your question already.
More things.
Yeah,
okay.
I'll just for everybody's knowledge, I'll just say there is a button that says reactions, and then when you click that, it says raise hand. It's just for everybody.
You have to click on that button. Okay.
Yeah.
Okay. Well, I assume I clicked it then.
Yeah, go ahead.
Okay, so I'm going to take the liberty. Actually, I want to really say something, and instead of, I mean, really just being corrected because I've been lesson for 20 years, right? Just telling people to use Python. And the question I hear most often, or the so-called, I don't know, arguments, are these two, I think, the most basic things. So I thought this is really totally, in Chinese, they're famous saying called you're showing off your carpentry skill in front of the master carpenter. But I really have to say was so the two things. One is people just say, I don't like Python, Python is untyped. After all these years of teaching, I don't know, Scheme and going to Java or whatever, C++. Okay, so my answer to that was, well, Python is not only typed, Python is strongly typed. Okay, so you cannot add one to some object reference and hope to get something right. And the only thing it's enforced at runtime when your program runs. It's not enforced when you stare at your code statically. Okay, but of course, type is, I mean, C, of course, type, but it's weakly type, right? Like you do all crazy things, have seg faults or whatever, core dumps. And then what's even worse was having to give you something appear to be the right number. You didn't even know it didn't give you a core dump. But I think most importantly was type, of course, is important. I got the right type by steering my code. But the most important is it's not just I got my integer. I want to steer my code. No, I got my correct integer value. Okay, and being able to write a totally simple and clear readable for loop or definition, and even better comprehension. You don't have to write for loops or recursive functions. And that's just totally important. Okay, so that's my question to the untyped arguments. And the second one, people say, especially more, like, later people will say, oh, Python is popular because it's the libraries, the rich libraries in Python. And to that, I say, libraries, has to be written by people who had chosen Python in the first place to write those libraries. Okay, the many languages earlier, better, more famous, and they did more libraries. Python became popular not because it's for business, like for COBOL, or for the military, like Ada, or Java. When we start with the hype of web, it was just picked up by school children, by most advanced scientists, because you get their work done more productively, and it's just fun to programming. So there's something more fundamental, right? Not just the libraries. Of course, I had a little suggestion what I think. So, but in fact, my first question for Guido, I don't know, was what do you think is the root reason for Python's success? Of course, to me, the root reason was, of course, Guido was there then. But besides that, the next level, what are the root reasons?
Dang, yeah, I was gonna say it had a lot to do with being there at the right place and the right time. I also used to use the expression standing on the shoulders of giants. There were really a lot of things that I just learned and almost didn't know any better because of the sort of somewhat protected environment where I grew up in sort of at the edge of academia, programming, but sort of learning a lot from Lambert Meertens and his team about language design during the sort of construction of the ABC interpreter. So my contribution probably has been to sort of take ABC and sort of transmogrify it into something that still is reminiscent of ABC and keeps enough of the sort of useful and interesting parts, but at the same time make it more practical for initially, especially a Unix environment. ABC was designed for a different kind of environment. It was almost designed for a world where for sort of a microcomputer like a Commodore 64, which is something that I never owned or used or even saw really, because my first computer was a mainframe. But ABC was designed to sort of be the only thing that the user used to interact with a computer. And somehow my own experience that I brought to the world of ABC and was like Unix, which is a system where you have many small or smallish programs that work together and can be combined in interesting ways. And I wanted Python to be another sort of small component that you could link up with the rest of the world through typical Unix primitives like file system, processes, later network connections. And somehow I sort of, by taking the clear elegance of ABC and sort of the notational elegance of that, but sort of removing a little bit of the theoretical sauce. One thing I dropped was actually a static type checker. ABC had both dynamic type checking and static type checking. So at runtime, it worked much the same way as Python. You had variables that were untyped, but objects that were always of a specific type, and structures that sort of contained elements of potentially different types. And if at runtime you encountered a situation where you were trying to add, say, a number to a string, it would give you an error. But in ABC, there was the idea that I think was never fully realized, that there was also a static checker that would actually look at your code and say, hey, it looks like if you were to run this program, you would be adding an integer to a string here. And we can't have that. So please fix it before you can even run it. That part I dropped completely from Python. And looking back, I'm actually glad that I did, because it made Python sort of simpler to implement, and that made it easier for other people to contribute. And that in the end sort of contributed a lot to the success, that I could sort of reel other people in and say, here, I got this small interpreter for an elegant language, go play with it, find things to do with it. If I had tried to also implement the static type checker, I would probably have spent the next 2 years getting the static type checker right, understanding why it's so difficult to have a static type checker for an object-oriented language. As it happened, I skipped that step and said, well, okay, if that integer and that string meet each other at runtime, it's just going to be a runtime error. And I added exception handling, so the code could even take care of that error if it wanted to. Not that I recommended everybody put try except everywhere, of course. And then, like when Python was more than 20 years old, someone else who had thought long and hard about this problem sort of contributed an idea for how to do static type checking for Python by adding type annotations. So I'm sort of looking back at, I mean, I was part of that project for a while. That was my part, but it wasn't my idea. The only idea that was mine was to sort of change the syntax so that it remained compatible with Python as it was at the time. But sort of, I realized that I really sort of escaped safely by skipping that step in the early phase of the language. I mean, there were many areas where I sort of took a shortcut and thought by myself, we can do without this, the user can figure this out, or the user probably isn't going to need this. And sometimes I was wrong, and then we added it later. And in many cases, sort of, that formed the language. Yeah, by sort of omitting the difficult parts made it easier to evolve it later somehow.
Wow, I didn't know that. That sounds so amazing. Actually, at first, he I guess his job, he just came back. If they heard that, he would be jumping up because there were things that's just undecidable for the most powerful type system you want. Okay, I see a lot of raised hands. I think Peter was the one asked long before. So Peter, go ahead.
Yes. Okay. So my question is maybe pushing the limits of what the topic is, usability and evolution. My question is, how does the properties of the language itself affect usability and evolution? An example, if your language would support capabilities, it would be easier to make it secure. If your language would have a subset that's confluent, it would make it easier to avoid race conditions. And for example, is it my question clear? I don't know.
I'm not sure what the question is, but sort of.
So would you you say that in the abstract, all kinds of problems, people have different goals. It's hard to evolve the language. How would the properties of the language itself affect all this? For example, people start doing highly concurrent programs, and because of the way the language is designed, you have piles of race conditions. Maybe your monitors are not nice or whatever. The language would have been designed differently. That would have not happened, for example. Or I don't know.
Well,
I'm more interested in language
in
property.
Python. Okay. Concurrency in Python is not a super pretty story. So
that's too bad.
no, that sort of, that is definitely something that is still evolving. We're still debating in the core dev team what to do with the global interpreter lock, for example. You might have heard of it. I was thinking yesterday.
Okay, you're still really thinking about concurrency. Then be warned. There are certain ways of doing it that are much better than other ways. I mean. Make sure you make the right decisions. Now you have the opportunity to do something, do it right or something. I don't know. I'm not an expert on Python, so.
Well, most likely it's going to be solved in the library.
Ah, so it's a library issue. Oh, that's a short-term solution, right? Eventually things go into the language and disappear. Things that have to stay in library. In 20 years, you don't want all that to be in libraries, right?
Oh, yes, you do. You want that there's actually a trend to sort of, you say you don't know much about Python, so maybe you draw.
I know a lot about
boundaries.
languages, but not about Python specifically.
Okay. I think you need to mute your microphone, because every time I say something, you interrupt me, and then I can't hear what you're saying. So we have a failure to communicate here. And if you want to take over the session, be my guest. I mean, I didn't prepare anything.
I'm sorry if I offended you. I didn't want to be offensive.
You
But
didn't offend me. I can't handle the sort of inherent the sort of half duplex nature of Zoom. So if you interrupt me, I can't hear you. And so you have to wait for me to finish speaking a sentence, and sort of I'm going to give you another break. I'm going to take another break, and you can say some more, and then maybe you can give me some time to respond. Okay, he's paused. I'm sorry for getting upset, but it's like it's physically very difficult to have a conversation over Zoom where the audio is like arbitrarily cutting off, and I literally didn't hear half what Peter was saying. I think he has an agenda. He would like everything that's important to him, like security or concurrency, to be part of the language and solved right once and for all. Python's approach is actually that as many things as possible should not be part of the language, at least not of the core syntax of the language. Because once it's in the core syntax of the language, it can never change. And now you can say but once it's solved, it remains solved, and that's a very mathematical approach to language design. But Python is not all that much of a mathematical language. I mean, I'm very glad to hear that Annie is so successful sort of with her use of Python. But the majority of Python users, and the reason that Python is a name that you all have at least heard of, even if you've never tried it, is that it's useful in sort of engineering applications and data science and machine learning, and literally fields that weren't invented when I created the language, and in many cases fields that I still don't understand exactly what people are doing. I have no idea what machine learning is really all about. I have very limited understanding of data science. If you ask me the truth, I don't actually know how web applications are built anymore, even though that is a major use for Python. And sort of the different types of applications may have needs for different types of, say, security or concurrency or any other sort of property that you would like perhaps to assign to the language, but that sort of you'd end up sort of building one particular approach to security into a language. Security, I think, is a good example of something that you don't want to build into the language, because as sort of 30 years of the World Wide Web have shown, there are always new problems in security. And so if you build a solution to the current decade's security, sort of major security issue into the language, then 10 years from now, you're probably going to have a legacy solution whose approach to security is limited to what was sort of on the top of mind of security researchers a decade earlier. And sort of, as a language designer, I don't want to sort of stifle that evolution. And so I sort of, Python currently has a very rich standard library. And in addition, there's a huge ecosystem of third-party libraries. What we find is that in many cases where the standard library is really some kind of application of underlying technologies, for example, a library for accessing URLs over the internet, we find that third-party solutions are actually able to evolve more quickly and adopt new approaches that sort of work with the ever-evolving world of internet. For example, we currently have this huge dependency on something called OpenSSL, which is a library for doing the TLS protocol. It's no longer called SSL, but it's still SSL in the name of the library. The TLS protocol evolves faster than Python can keep up with it. And we would wish that we had a higher level set of APIs that could be implemented using the platform's network stack, which is usually considered more secure than OpenSSL, at least on the platforms where OpenSSL isn't the only solution. And so I'm glad that at least networking is all sort of library stuff in Python, and there isn't any sort of particular approach to network programming or security built into the language. And that's probably where I want to leave this particular question. And I'm sorry I got upset about Zoom, but that's just, it's frustrating.
Yeah, sure, no problem. I have this problem all the time. So I see a lot of reasons, some even a job to be waiting for so long, but I actually do not remember which one did first. Maybe Paul, can you go ahead?
Okay, I think I'm probably second, but not sure. Okay, let me get to the first comment or question. I wrote about 4 Prolog compilers from one end to the other, but I'm more fluent in Python currently than I'm in Prolog, partly because the language has a lot of deep family resemblances. That's, well, in Wittgenstein's sense, languages that intercommunicate in a deep way, even if minor things like do we have a loop or we don't, how we implement set comprehensions here and there, and so on. All those minor differences between the two paradigms are actually easy to ignore once you are genuinely fluent in the two of them. And then you actually can very easily program in a, let's say, logic programming style in Python by using something very nice that you have the yield statement and well, the coroutining mechanism actually. So my question would be exactly about that. What brought the coroutining mechanism in Python? What was your thinking when you brought that in? Because it's a very, very powerful one, and now it's spreading all over in virtually every language. That's still popular and interesting. C# has it recently, and so on.
That's actually a very interesting evolution because there were so incredibly many steps involved. Believe it or not, in the very first version of Python, there were for loops, and there were, I think, 3 data types that the for loop could iterate over. It could iterate over a list, it could iterate over a tuple, or it could iterate over a string. But I had anticipated that there would be other data types defined by users, probably by writing C code originally. And so I had left open a little escape hook so that user-defined types could specify how they would be iterated over. And sort of, it turns out that the design of that escape hatch was wrong initially, because the paradigm was everything is like a list that gets indexed. And so the original implementation of the for loop was probably closer to ask the list how long it is, then generate all the integers from 0 through n-1, try and index the list with that index, and that's the next value you get in the iteration. And so the first thing we ran into was sometimes people would add elements to the end of the loop while of the list while the loop was running, which is kind of nasty, but it should at least work and not just ignore those extra things. So we started generating consecutive integers, not stopping at n, but just keep going until we hit an index error, which is specific error that the list is supposed to return when there is nothing at that index or beyond there. Then we introduced an iterator object that represented the state of the iteration. That was an interesting abstraction, although it was sort of almost invisible. It was the sort of a place that kept the internal integer counter that was incremented and used to index consecutive elements in the thing you were iterating over. It was no longer always a list. But the iterator was an object that had a specific API, and we actually spent a lot of time debating what that API should be, especially sort of when you ask for the next element of the iterator and there is no next element because you've exhausted the underlying list. What should it do? Should it give you a specific sentinel object, like there was a none in the language? Should it just give you none? But what if a list contains a value that is also none, that would be confusable by the end of the list? It's just as bad as null terminated strings in C. So that was outright rejected. Then there was like, oh, the design could be like, first you ask, is there a next element? And then if that says yes, then you ask, give me the next element. It's a clumsy API. And then we said, well, what if it just raised an exception and the for loop caught that exception? That is also clumsy, but that's the one we chose. And maybe it wasn't so bad because at least it's an atomic operation. You ask for the next thing and you either get the next thing or you get an exception. This was still an object with like, there was a next method or yeah, I think at the time it was called next and not underscore next. And then people started saying, but wouldn't it be nice now that we have this general iterator structure, if we could write, instead of having, you basically had to define a class and define a method next in the class. And manage the state. And people sort of observed, well, all the state could actually be one or two local variables in a function, and the function can just sort of at some point tell you, oh, return this value for the next value, except it's not returning because there's no coming back after a return. So I forget, someone must have seen this in another language. I can't believe that we were the first to invent coroutines, but the specific syntax sort of came from the Python community, I think in the mid to late 90s, actually. And so now we had generator functions with the yield statement, and that actually, initially it was only a statement, just like return, and then someone said, but we could do other things with this, and we sort of yield became an expression element, and now you could send a value into a generator, and that would be the return value of yield, and then the function could do some computation, and now you had a much more sort of equal alternating between two parts, and one part is the for loop and the other part is the function, except that the driver doesn't have to be a for loop. You could sort of manually send things and then call the next method. And if you thought that we were done with that, at that point people said, oh, but we can use this for a sort of asynchronous IO. And a new thing was added again, where this actually took several releases. We almost had a design ready for Python 2.5 or 6, and at the very last moment I got cold feet because there was someone who made a very serious objection, and there was no time to debate it. And that particular Python 2 version went out without yield from, and then sort of debate died out and nobody was interested in talking about that. And then it came back somewhere around, I think, Python 3.3. And then yield from was made the basis for this whole asynchronous IO library that I co-designed, but I took ideas from various other asynchronous IO libraries that had by then evolved in the Python ecosystem. And then another contributor after a few releases said, this coroutine decorator that you apply to functions, to generator functions that contain yield from, wouldn't it be much cleaner and more elegant if we made a keyword that declared that as an async def? And that was like a revolutionary insight, that this was actually so important that there should be a language keyword to indicate it, rather than sort of using some library trickery. And again, sort of once we sort of had the idea of spelling the yield from as await, the semantics became much clearer. Even so, the sort of as a user interface to teach it to users and to let users think about it the right way, an async def with an await expression in it is much cleaner than the coroutine decorator we had before with the yield from, because everybody was wondering, what does yield from stand for? Why do I have to spell this yield from? People were always saying, oh, why can't I just say yield? And there was a very deep, important reason that we just couldn't understand until we had sort of renamed the concept from yield from to await. And then suddenly this whole sort of asynchronous IO paradigm started blooming, and there were competing libraries developed in the community, and that's sort of where we are now. But that took so many steps, from sort of being able to iterate over both lists and strings to having an sort of asynchronous
That's one of the, sorry.
Yeah, go ahead.
That's one of the most involved, I think, features of Python, the complex control, right? We want to keep all the clarity. So actually, I saw Benjamin, we are almost running out of time. Benjamin, do you have a quick question? Oh, we can't hear you, Benjamin. At least I can.
He's
I'm sorry. It might be quick. It's up to Guido to see how quick he can answer it. But do you feel like in an ideal world, you could somehow morph Python more in the direction of logic programming or set-oriented programming? What's the right route to that? Is it to maybe have libraries or something like that, or to modify the, let's call it the core language itself?
For that, I suggest that a whole new language that sort of can freely borrow ideas from Python, but can also freely reject certain parts of Python would be the way to go. Because Python has so fundamentally built into it this notion of mutable data structures. And it's easy enough to sort of refrain from using mutations if you're writing a small piece of code, but if you haven't a team of engineers who are maintaining 5 million lines of legacy code, there's no way you can stop everyone all the time from using those features. And so that will remain in the language forever. And the only way to make forward progress in the direction of logic programming, if that's where you want to go, is to start over, like I started over with Python, taking great ideas from ABC, but also rejecting certain parts of ABC. Like I also rejected the use of uppercase letters in ABC because that wasn't Unixy. So that's what I would strongly recommend, and that can be very fruitful. And I hope that was short.
Okay, thanks. I mean, I just would observe we've been doing work, Terry Swift and others, especially on bridging between Python and Prolog. And one of the things that actually makes it easier is the fact that the data types are a fairly similar set to Prolog. And, you have this, relatively weak typing compared to a lot of other programming languages. That
That's a
makes
good
it
point.
very flexible,
I have to say, there were more questions in there, and Peter helped answer some. And I saw Ed just raised his hand, and Tunja has been raising hand forever, but I think I'm going to have to stop people. And as I said, I will ask you guys to write the questions down, and if there's anything, I'll collect them. I will send to the speakers and hope they will answer. Okay.
Yeah. I agree. So we are a little bit.
Yeah. Also, Tunja is the one who take care of the rest. But thank you so much, Guido, and thank you everybody for the questions.
Of course.